Okay, Coroneos 100 integrals, number 29. For this question here, there's no obvious way of sort of like changing this 5 plus 3 cosine x into anything, so we can integrate it very nicely. Can't really do any sort of like a substitution. If you try to use u equal to cosine x, it's not going to lead you to anywhere. So when it comes to a question like this one here, with a fraction and or even without a fraction, but you do have something like a number plus trig ratios, usually the approach is using the T formula substitution. So we can convert these trig ratios back into the normal, algebra in terms of like a t, a polynomial kind, or maybe a reciprocal function in terms of t. Okay, so the first step we'll do with this question is we are going to let t equals to tangent x on 2. Remember, this is T formula substitution, so that's what we need to do. We need to differentiate both sides. All right, so dt is equal to sec square x on 2 times by half dx. Now remember, if you pay attention to this dx here, I've got dx there. So basically what you want to make a dx as a subject. So you want to change all of these back into the left-hand side. So therefore dx is as a subject. So I want to times everything by 2. So that gives you 2 dt is equal to 1 over cosine square x on 2 dx. All right, because sec the square is equal to cosine square x on 2. Now once you finish that, we can move this one back into the left-hand side. So if we change that into back into the left-hand side, we end up with 2 cosine square x on 2 dt is equal to dx. That's a pretty good step, but we still haven't finished the question yet. Have you noticed that on this side, on the left-hand side, I've got in terms of t, dt. However, what's inside here is x. So x and t shouldn't be in the one expression there. So we need to replace it. From here, we should be able to create a right angle triangle. And by using this right angle triangle, we should be able to find out what is cosine square x on 2. All right, so tangent x on 2 is equal to t. So therefore, the hypotenuse, adjacent, that's not the hypotenuse or adjacent side, that's the opposite side. So the opposite side is going to be t, adjacent side is going to be 1. So we're going to label here t and 1. The hypotenuse is t squared plus 1. Okay, so once you finish this, we now can find out what cosine square x on 2 equals to. Cosine square x on 2 is adjacent side over the hypotenuse. So therefore, that times by 1 over square root of t squared plus 1 and square root dt is equal to dx. So now after we simplify it, we end up with 2 over t squared plus 1 dt is equal to dx. So finally, we get what we need, okay? So finally, we get this expression here, and that's what we need. We want dx in terms of dt. Okay, now we can start to do the substitution. We also need to know one more information. We need to know, for the t formula, if t is equal to tangent x on 2, what does cosine x equals to? The cosine x is equal to 1 minus t squared over 1 plus t squared. That's just the t formula for cosine x. So therefore, we can replace that cosine x by everything here. All right, so let's start to do the question. All right, so finally, we can actually do the question now. So the dx, which is on the top here, now it's become 2 over t squared plus 1 dt. So I'm just going to change that into 1 over first, and then I'm going to times by 2 over t squared plus 1 dt. The denominator is going to be 5 plus 3 cosine x. So in that case, it's just going to be 3 times by another fraction, 1 minus t squared over 1 plus t squared. All right, it's not a very nice. Okay, so I guess what I need to do is probably just rewrite it to make this a bit clear for everyone. Okay, so integrate 1 over 5 plus 3 times by bracket 1 minus, that's not a minus, 1 minus t squared over 1 plus t squared. Okay, all right. Next, we are going to expand. But before we do that, let's just multiply the numerators together. So 2 times by 1 is just 2 over. Now we need to multiply the denominators. So we're going to times the 5 with the denominators there. So we end up with 5 bracket t squared plus 1 plus. Now the next one is that's t squared plus 1. That's also t squared plus 1. So if you multiply these two terms together, this cancels out. So which means you end up with 3 bracket 1 minus t squared. Okay, 1 minus t squared. And dt. Okay, next we need to expand the denominator. So we've got 2 over 5t squared plus 5 plus 3 minus t squared dt. Okay, now the next step here is we just need to simplify the denominator. That gives us 2t squared plus 8. Okay, so that's something that's pretty easy to do now. Alright, so the next step, simplify the numerators and denominators. We'll get 1 over t squared plus 4 dt. And that's just the formula we need to use to integrate. It's going to be the inverse tangent. That's 1 on 2 tangent inverse t on 2 plus c. Again, we still haven't finished the question. We know t is equal to tangent x on 2, so therefore we need to substitute all of these back into the t. So all of this back into here. So we're going to substitute this one back into here. So that gives a half tangent inverse bracket tangent x on 2 over 2 plus c. Alright, so that's it. That's the answer to this question here. So this is a pretty tough question. You need to realize this question has to be done using the T formula substitution. So you can change the cosine x back in terms of something in terms of t. So hopefully it's just going to be an expression in terms of, an expression in terms of t. So we don't have to integrate with respect to the trigonometry functions there. All right, the hard part is you need to prepare your substitution. So you need to be able to differentiate both sides here and be able to rearrange all the steps until you get the final step to here. So you end up with like dx is equal to 2 over t squared plus 1 dt with the help of the triangle, of course. Even after you finish this, the substitution takes a while to do. You need to pretty much know your algebra really well before you can simplify into the correct form. And then you need to realize that's reverse, an inverse trigonometry function after you integrate it. And don't forget, you also need to substitute the numbers, this t equals to tangent x on 2 back into the expression. Okay, thanks for watching.